Okay, so simplifying more complex fractions. We looked at one of these yesterday when I did it during fourth hour or fifth hour. I didn't have time because of the shortened hours, so they didn't actually do that. So, but we're going to do one of these problems today. So we have a more complicated fraction, but really this isn't, because all this really is 3 over x plus x over 2 divided by x minus 1 over x. Okay? It's the same thing as that, which is just what we've been working with. So the only difference with this problem is that in the numerator, okay, the top part, so up here in the numerator, we need to get a common denominator first. But then we have a fraction divided by a fraction, which to simplify that, we just copy, change, and flip. So first of all, we need to find the common denominator in the numerator, which is just going to be what? What's our common denominator up here? X times 2. Okay? The common denominator is going to be 2 times x. The left side doesn't have a 2. The right side doesn't have an x. So my common denominator is going to be multiplying them together. Okay? So we have a denominator of 2x, which means I have to multiply this by x over x and this part by 2 over 2. So we have 6 plus x squared over 2x. And then that is all divided by x minus 1 over x. So we have a fraction divided by a fraction. So we're going to copy, change, and flip. So I'm going to rewrite this as x squared plus 6 over 2x times, well, let's see how good I am today. All right, making Jenny mad at me.
Doesn't make me mad.
I know it. So look at that. Hey, I just copy, changed, and flipped. All right. Isn't that cool, though? It'll do that?
Cool. I just wish we could do that.
I know, I know. You know, one of the things I tried to do last year, I had for a little while. Were you in the class I had this little tablet thing? What? And I really wanted to get a classroom set of these. And they had the smart software on them. So each student could have, basically you would bring a flash drive and you could have access to that. And, you know, you would do the work on it just like I would, because it came with a stylus. And then you could just save it to your flash drive and, you know, take it home, and you could bring it up on the computer or whatever. You could put it up on, you know, you could put it up on Google or wherever, and you could have access to it, just like I do with the other stuff too. So, but yeah. But yeah, you could have all the colors, do your own coloring of notes and like that. So,
I like writing.
yeah. Well, you would be still writing,
I
but
like how everything gets put on computers these days.
yeah.
Oh my gosh, since we're talking about computers, I am the worst person with computers. I was at Career Center and I was making these business cards for my class, and I could not figure out how to go in Word and figure out how to change different things.
I'm good with design stuff. It's just I don't like going on the computer because I have to do an ACT
Mm-hmm.
on the computer because my class was chosen to do it.
Oh,
I
wow.
have to take 2 ACTs this year.
Really? Who's that? Where's it?
It's with Miss Mass's class, 4th hour. We have
Really?
to take it on the 30th.
Well, at least you don't have to pay for it.
Oh, this month you're doing it?
Yeah.
Oh, okay. All right.
You don't have to pay
Okay.
for it.
So here's my answer.
It's just stupid though, because they want to switch everything online.
They are. Yep.
So every grade, after that, has to take their ACT online.
Yeah, it's getting crazy. Okay, so let's look at some story problems about rational functions. This is a transportation application problem. So it says a hiker averages 1.4 miles per hour when walking downhill on a mountain trail, and 0.8 of a mile per hour on the return trip when walking uphill. What is the hiker's average speed for the entire trip? Round to the nearest tenth. Now, it's more complicated in a way than just averaging those two numbers. Okay, it would be really nice if I could just average those two numbers to get the average speed. The problem is that you have to involve time in it also. Okay? So we'll call her, or this hiker, we'll say that their D represents their distance. Okay? And in this problem, they're going downhill and uphill, right? And what do we know about the distance going downhill and the distance going uphill? It's longer downhill? Or would it be the same? It would be the same, okay? So the distance going downhill, so we'll say distance downhill, we'll use a capital D to represent downhill, is the same as the distance uphill, okay? Which we're just going to call that D then, okay? So we want to make that clear. That the distance going downhill is the same as distance uphill. Now, since they want to know the average speed for the entire trip, that means our total distance is going to equal 2D, right? Okay. All right, the distance there and the distance back. Okay. Now, distance, now we need to get into the rate and time thing, okay? Distance equals rate times time. You've seen that formula before, right? D equals RT, right? Well, our distance in this case is D, and our rate, well, let's see. We've got two different rates, don't we? Okay. So the distance downhill is equal to a rate of 1.4 miles per hour times the time, and the distance uphill is equal to 0.8 times their time. Well, what we need to find out is we need to find out their total amount of time they traveled, right? Because to be able to find their average speed, we need to know their total distance, total time. So the time here for downhill is equal to D divided by 1.4. And their time uphill is equal to D divided by 0.8. All right, so far, are you okay with what I've said? Okay, it's a little complicated though, right? Now, we want average speed. Okay, the average speed for the entire trip is going to be the total distance divided by the total time. Okay, so for instance, if we drive to Chicago, all right, and back, to figure out our average speed, we would take the total distance. And so let's say it took us 5 hours to get there and 3 hours to get back, or 4 hours to get back. That'd be pretty fast, 3 hours to get back then. But if we took our total distance then and divided by the total time, we would find the average speed, okay, for the whole trip. So what we have to do then is we need to take the total distance and divide by the total time. Okay, I'm going to need more space. All right, so this is their average speed here. So what we need to do now is we need to simplify this rational expression to find the average speed. So what will we do now to simplify this? What do we need to do? We need a common denominator in our denominator. Okay? So that means we're going to multiply this part here by 0.8, excuse me. And this one by 1.4. So we have 2d divided by 0.8d plus 1.4d over. And what's 1.4 times 0.8? What is it?
1.4.
Okay, 1.12. All right. So now I have something here divided by a fraction again. Okay. So we have 2d, and instead of dividing by the fraction, I'm going to multiply by the reciprocal, right? Okay. So the numerator is going to be 1.12, and in the denominator we're going to have, what's 0.8d plus 1.4d? How about 2.2d? Okay. So now look what happens here. With this multiplication, we can cancel out the d's. So distance is gone. And now it's just a little bit of multiplication and division here. So 2 times 1.12 divided by 2.2 equals what? 1 point what?
1.018.
Okay. 1.018. And that would be miles per hour. So to find this, we had to first of all find the total distance. Right? The distance uphill, the distance downhill, and the distance uphill represented the same thing. So I could use just d to represent distance because it represents both of them. They're the same. Okay? So the total distance of going uphill and downhill was equal to 2d. Okay? Then to find the average speed, then we need to look at time. So we need to find the time uphill and the time downhill. So our time downhill is represented here by d divided by 1.4 because he went 1.4 miles per hour downhill. And our time uphill then was represented by d over 0.8 because he went 0.8 miles per hour uphill. So then, to find the average speed, then I have a fraction. I have my total distance in the numerator and my total time in the denominator, and then it's just a matter of simplifying that fraction. So those are the main key points. That is just to start with, what's my total distance? What's my total time? And it gets a little complicated because you end up using expressions to represent them instead of actual numbers.